Ryan's going to tell us why we cannot have Unix socket act like synchronizable events in the same way that TCP listeners and acceptors do.
So to clarify, you cannot have Unix socket accept event that acts the same way that TCP accept event does. So Unix sockets currently do act as synchronizable events that let you know if they think that they're ready for input, output, whatever. Okay, so when you create a listener, you create a socket, that gives you a file descriptor, you bind it to an address, you call listen, that tells the operating system, people who want to connect to this, go ahead and allow them to connect, build up an internal queue of waiting connections.
Okay. When
you call accept, so you also have to put the socket in non-blocking mode in order to be rackety, otherwise you freeze the whole VM, and that's bad. Okay.
And that essentially makes it so when you call accept, you get a null.
Like that. You get -1 with error no, E would block.
Sure.
Or E again. Yeah.
Whatever. You get a signal.
You get something you get something telling you no, there's nothing ready.
Yep.
Okay.
So the question is, how does Racket accept but not accept if the event isn't chosen?
So in order to cooperate with the event system, you want something that you can try to accept immediately, and it just says no, right? Mm-hmm. So how do you, for example, sleep until something is ready?
Yep.
Well, you can use the file descriptor to waiting on the file descriptor. You can use poll or select or epoll or whatever. To wait until some connection is ready, probably. And I've not been able to find out if the file descriptor gets woken up, whether a connection will definitely be available, or if a connection can arrive and then the connection can be closed from the client side before Racket gets around to calling accept.
Sure.
And that's the case that I'm worried about and that I want to guard against.
Okay.
Okay.
That seems obviously possible.
So you were not coming?
I might be coming.
So it's the main thing that I'm worried about.
Okay.
Right. So from a file descriptor, you can get a semaphore that becomes ready when, or that becomes ready when there's something
interesting.
Yeah, when something happens.
And when you say a semaphore, you mean a Racket semaphore.
A Racket semaphore, which is a synchronizable event.
Yep.
Right. And so and then you can actually try to accept, and it'll say, yes, here you go, or sorry, nothing was ready.
Uh-huh.
Okay. So those are the two pieces that you have that you want to combine into an event that has this property that it becomes ready if it is plausible that there's a connection waiting.
Okay.
And it is chosen for synchronization if and only if the call to accept actually gives you a connection back.
Okay.
Okay. So.
And it only chooses does the accept if it chooses that event.
Yes. Yeah. So there's a very important if and only if there.
Mm-hmm.
Okay. So those are the two pieces you have. You have the event that might give you false positives, and then you have the function that will tell you, did you actually get something, or was it a false positive?
Yeah.
Okay, and there's no combinator that puts those two together into the event that has the if and only if property.
Does the C code have that, but it's just not exposed?
Yes, you can. So you can do this in the C code because you have. So events are divided into kind of wake up functions that install whatever.
Like an alarm?
Well, so they do things, for example, with select or poll or whatever. So you can say, I wake up if something happens on this file descriptor.
Okay.
Or whatever primitive support there is, right? And then there are the, I forget the name. There's the other function that actually tells you, can I choose this event, and if so, what is the result?
Okay. And there's a third category.
Excuse me. So those are the two parts of events at the low level.
Oh, okay.
Right. And so, for example, TCP accept event does the same thing for the needs wake up bit. It says listen on this file descriptor, and then the C code, the are you actually ready, will call accept. If it fails, it'll say no, I'm not ready. Go keep trying to sync. Otherwise, if it succeeds, then it actually creates the TCP ports and sets that as the synchronization result. Okay. The problem is you can do all of that atomically at the C level, but not at the racket level.
Okay.
Right. So if you had a combinator, perhaps an unsafe replace event combinator.
The promise to call the replace event callback atomically.
Yes, they call
And
it
that's
atomically.
That's what would make it unsafe?
That
Like, why does it have to be unsafe? That's the thing I'm not sure about.
Because if you're applying a racket function, you don't want to freeze the syncing.
Yeah, you can't.
The synchronization.
You can't use atomicity and racket level operations safely.
So we're using unsafe in the sense of like trusted, basically. You gotta
Yeah,
trust that this
kind of.
code doesn't go interact with other
Well,
synchronization.
no, you can. If you do call with atomic printf, that just segfaults the VM.
Okay.
People keep
May
asking.
segfault the VM.
People
is
ask-
likely to segfault
People
the VM.
ask about this on the mailing list on a regular basis. Like, I required FFI/unsafe, and then I called this function. It doesn't seem to obviously access memory out of bounds, and then Dr. Racket goes away. Why is this unsafe function in the why is this function from the unsafe library unsafe? And the answer is because that's not safe.
Okay.
So there's some stuff in the documentation about unsafe, atomicity, the racket scheduler.
And that's what it comes down to.
That's what it
So
comes
just
down to.
so,
So
it
in
seems
particular,
like unsafe replace event, unsafe atomic replace event, is a straightforward thing to add.
Yeah, but we started this by you saying that we can't. So like, so Matthew told
no,
us.
it's so the problem is that it's just not there right now.
Okay.
And it's very difficult to write, or so as of the last time that I had cycles to spend on this, it was very difficult to add because it's very difficult to add new scheme types from the FFI because it's very awkward to add the GC traversers for the new scheme
Oh,
type.
but Matthew fixed that.
Yeah, so Matthew fixed that as a result of this conversation.
Oh, okay.
Okay.
So it might be somewhat more feasible now, but I think there would be a better solution. I think would just be for the FFI to define this unsafe replace event, which seems like a reasonable unsafe combinator for creating events.
Yeah.
So I think that's the right solution.
That seems
Cool.
And then that seems like one of the right things to taking like TCP and UDP out of the runtime, which
Would be nice.
do not belong in the frickin' runtime.
I wonder if there's more complicated stuff that happens with TCP support and UDP support that would make it harder to move it out of the runtime. But yeah, I think that would at least make it plausible.
Shall we say the explanation is done?
Sure.